Good afternoon. Welcome. My name is Eddie Thompson, and I am lead solutions engineer for Sumo Logic here in Australia. And what I'm going to talk to you today is about Kubernetes, and more specifically, our Sumo Logic solution for Kubernetes. So, as a bit of an intro, what is Sumo Logic? Well, we are the industry's first and only continuous intelligence platform. And what does that mean? Well, we take in your logs, we take in your metrics, we take in your security events, your traces, and allow you to provide some different lenses to this data across operations, security, BI, global intelligence. We'll touch on that a little bit more later. But basically allowing you to predict and optimize, search and investigate, monitor, alert, and basically have a consistent view of your data across various areas of your organization all at the same time across those common data sets. So what I'm going to do to start with is a little bit of an introduction to Kubernetes and some terminology around that. So apologies for those who work day in and day out with Kubernetes, but this is just a little bit of foundational information which is useful to understand for people who are newer to the concepts. I'm not going to be spending ages on it, so like I said, apologies to those who know this in depth. So basically, what is Kubernetes? It's an open source container orchestration platform. So it was developed by Google and they open sourced it, and it's now managed by the Cloud Native Computing Foundation. So it provides automated deployment, scaling, and operation of applications, or more correctly, services across clusters of hosts. So it provides desired state management. That is, that you tell Kubernetes what you want it to do, what you want it to do in its end state, and it organizes that on the background based on the criteria that you've given it. Now, everything in Kubernetes is by design ephemeral. So it achieves its ability to scale by being able to add and remove resources as required. So that means that things that have by nature possibly quite short life. So you can have pods that are there for hours, minutes, even seconds, theoretically. And most importantly, it runs anywhere. So that private cloud, public cloud, or even on bare metal. So the Cloud Native Computing Foundation, what is that? It's a non-profit. It's part of the Linux Foundation. And it has many members across the sort of hardware, software, cloud provider, vendor community. So it's a pretty broad and well-supported organization. Sumo Logic's a member. We're a silver member. Now, on to the key Kubernetes terminologies. This is just a little bit of language that makes some of the feature set a little bit easier to understand. So what is a cluster? So that is your main grouping of nodes. So basically you have a master node and many worker nodes. So these are basically the group of nodes is where your actual workloads reside. If you're used to VMware, your cluster terminology is probably similar. So the master node becomes your vCenter. The worker nodes are your VM hosts. So the node is the worker machine. That is a server. So that could be an EC2 machine, or that could be a physical host in a data center. The pod is important because that is the simplest organizational unit that you can deploy within Kubernetes. It is one or more containers. So important to realize that you never deploy a container itself in Kubernetes. You can only deploy a pod. So a pod may contain multiple containers. The container itself, that is the actual software image that contains the libraries and dependencies and software that you wish to run. And that is actually what executes the code that runs there, but it is only ever deployed as part of a pod. Deployment. So a deployment is a commonly used abstraction for how you organize applications within Kubernetes. So you have a deployment that may have many pods associated and can have some specific rules about how those things are deployed and how you would like them to operate. And they have their own set of relationships. So you may have many replicas within representing many pods within a deployment, but the deployment is how that is organized. Now, namespaces, like namespaces in many other computing terms, is used to abstract a cluster into virtual spaces that can overlap. So while you may not have a name of something duplicated within a single namespace, you may have duplications within many namespaces. So commonly people use namespaces for either, say, an application or possibly a development team or a business unit, but basically it allows you to divide physical resources into a logical virtual allocation within Kubernetes, and it's a sort of a key part of that sort of organization and how we actually organize things within Kubernetes. Now, service is a really important part of Kubernetes and ephemeral deployments in general, because this is what you actually present from your software to the world. This is what you actually have enabling you to interact with those underlying pods. So you may have things like a payment service or a user service or a map service or an authentication service. And the service layer is what, or a service mesh, is what is actually redirecting those requests which are received from externally to the pods servicing those requests within your clusters. And that allows for efficient distribution in cases of load. And also it means that when we have those scaling out events, that you're always being directed to the right endpoint. So when a pod disappears as ephemeral, the service mesh knows about that, and it knows not to direct it a request to that pod which no longer exists. So it knows where things are, and it knows the right places for these to go. That's the important thing. So our Kubernetes app, it provides visibility into these worker nodes and their application logs. It provides a metrics view of what is going on across the states of your environment. Things like health replication, load balancing, pod states, resource allocations. And we also provide Falco to monitor and detect abnormal behavior when it comes to sort of security and that sort of DevSecOps type of thing as well. So that's enough of me going through the slides. So we'll jump over and actually have a look into how we can use this within the Sumo platform and have a look at some live stuff rather than me just showing slides, which is always more interesting. So here we have my Kubernetes Explorer view within Sumo Logic. So when I'm logged in, to get to this window, I can click on New and go down to Explorer. I've already got one open here. And we can see here that I'm looking at the Kubernetes node view. So as you remember, that is the compute working space that the containers or the pods and containers reside on. Now I can see here that I've got several nodes. These are some compute resources from Amazon, so it's an EC2 instance. And also this is a useful way to see how things traditionally have been organized. which is an infrastructure-focused view. So when I click on one of these nodes here, we can see that automatically my dashboard has changed to something a little bit more relevant to this particular node, telling me things like the CPU utilization, number of inodes used, how many CPUs I've got, what my resource allocation has been like over time. But as I see here, what I can see is the pods which are running on this particular node, and they have no particular organization other than alphabetical. And these distributions will change over time because of the ephemeral nature of Kubernetes. Now, that is not the easiest way to find and locate possible issues that you may have with a specific application or service. It's not an easy way, and it doesn't fit the mental model that we have for Kubernetes. Now, you can see here that I've actually got several clusters here, which is quite common. Now, I can actually filter these. So if I wanted to filter it down to a specific cluster, I can do things like say, okay, I only want to show this one here, Proto one. And I can click apply and I filter that out. Now, that could be done across all sorts of information, things like AWS tags that you have within your environment, or any specific sort of other metadata that you wish to apply, or a service. But it makes it really easy if you're working across many teams and you have a lot of clusters and not everything is relevant to everyone else. It means that you can simplify it based on some filters, which really helps out in those complex environments. So anyway, as I mentioned, I've got my nodes here, and may not always be the best way to have a look at what's going. So we've got multiple views here. So it means that I can actually say, okay, well, show me the namespace view. And once again, I can see here now, if I filter down, I have my clusters, but now I've got various namespaces. So say I go into my prod loggen namespace, I can see there's some stuff going on there which I may want to investigate. Now there is a logically ordered list of my pods that are relevant to what I expect to be there, because it's sorting it via this namespace. Now, there's an important part to that which we actually achieve by our collection and some of the smarts that we've built into that, and I'll go into that in a little bit later. But basically what this allows me to do is see at a heads up what's going on within this namespace. I can see my number of pods running, pods which have had failures, and also things like which pods have got errors and which containers have errors. Now, what sticks out to me here is that Carbon Black, I can see that pod has got a failure, but I don't see it in my errors. So there's something going on with that, but it's not related to a specific error that I can see in the logs. So I can click on that, drill down into the specific pod that I'm looking for, and I can see here that the pod here is in what we call a crash loop backoff state. So I can see some events that have been pulled from the Kubernetes API server, and it's saying that there's a backoff restarting failed container, and it's been happening thousands and thousands of times. So it's not hitting any memory limits or CPU limits of the pod, but if I go down here, I can follow a little timeline to sort of see what's happening. So it says that we're monitoring, these are all metrics that we're monitoring from Prometheus. So what I can see here is the metric that we're tracking is container status waiting reason, and it's telling me the reason is crash loop backoff. And then the next in the timeline, I can see that we're starting it up, and it's saying container status ready. Immediately after that, we're hitting container status terminated reason, and that reason is OOM killed. Now, OOM killed stands for out of memory killed. So it looks like the scheduler is actually killing this off because there is insufficient memory. Now, that's a little bit strange, as I cannot see a particular memory limit being hit here at the pod level. So we'll go down and investigate a little bit further. And okay, I can see what's happening now. So we're running into a problem which is relatively common in that I can see my memory usage limits versus requests. Now, when a container is started, it makes an initial request for how much memory it requires. And in this case, I've got that, it looks like that's set to around 50 meg, but I've also got a limit, which is the maximum that it may use. And it seems that this container is exceeding that massively. So every time it starts up the container, unfortunately, we're getting stuck with it being killed off by the scheduler because it's using too much memory. Now, the important thing to note here is that because this is being killed off by the scheduler, there are no actual pod level logs which are throwing an error. So if I was not tracking these metrics, I would not be able to see through my error logs that I am having this particular problem with this this crash loop backup. So this is something that I'm identifying both via the metrics and also these events which I'm polling from the API server. Now I could work this out at the command line. I could sit there and type in kubectl show blah blah blah, but it's really not an effective way of troubleshooting, particularly if you have a complex environment. So that's one way, which is really nice to be able to sort of investigate why you may have a particular issue within a pod or within a pod in a namespace. Now, one of the other things I noticed here was that I had two issues with failures, but this one does have some errors. So we can look at the pod dashboard here for this particular one. Now I've just used my Entity Explorer drill down to do that. But here I can see that what I've got going on here, I've also got a pod crash loop back off, but I don't have that out of memory killed error. What I've got here is terminated reason is error. So there's still a similar issue, but a different cause. And it's saying back off failed restarting container. Now, if I go down here and I can see that it's not the same memory issue. So my working set bytes is well within my allocated limits. And so that's not the problem. There's something different going on here. So what I can do, I'll jump back up, and rather than go down to the pod level dashboards, I can actually sort of pivot over here and say, okay, for this particular pod, I'm just going to say, and briefly I'll introduce you to our Entity Explorer here. This is a useful way that we can sort of pivot through related things based on a particular entity I've clicked on. So I've clicked on this related to PagerDuty. And so that allows me, say, I wanted to look at the entire deployment, or if I wanted to look at something for the namespace, I could do that as well. But what I want to do here is, for the pod, I'm actually going to go to the underlying logs. So what that's done for me is filled in the same time range, but also automatically filled in the relevant metadata. So right down to this ephemeral label for this particular pod. And what I can do here is see the underlying logs and have a look through the logs, see what the likely issue is. Okay, so I can see a Java exception here with a 401, so that's looks like an authentication issue. I can see an access key and an access ID here. So what I might do is check this particular access ID. So I can just actually look across any of my logs here for this particular access ID. I might do that for the last few hours. I've got a few results here, so I'll hit log reduce. Basically, this is a pattern matching algorithm. Apply some advanced analytics and lets me look at the values and clustered values of logs and the structure of them. Okay. So it looks like someone from the SOC has actually deleted this particular access key. So the user, Kenneth, had a particular key associated with them, so it's been disabled and deleted. And that would explain why we're seeing some 401 errors, unable to authenticate. So that's that's shown me that there's actually a bit of a human process issue that's been discovered here, but it's been surfaced up through the fact that I've got a faulty pod. But these are the things which are useful to be able to do. It's not always a configuration type issue. Sometimes it's a human process issue. So we need to improve our offboarding process, looking at keys which are in use before we disable accounts which may have live authentication details associated with them. So that's another sort of way, but the important thing here, really easy to directly pivot, point and click to some underlying logs in an ephemeral environment, something that's very powerful. Now, one of the things which is important here too is the fact that as I pivot through these particular views, I'm able to see what's going on in a logical sense. So when I go to this particular namespace, I can see there is a service related. I can see the pods that are related. If I look through the others, I can see things like what's going on with my Floyd D service, the related pods across that service are all logically shown to me, and I can see that there's no problems with this particular service, how many pods I have running, they're all in a useful state. But if I wanted to have a look at my service health, I don't have any particular data for that one because it looks like I don't have some trace data associated for that one, unfortunately. But basically, this gives me a really, really simple, easy to follow, easy to locate way, because when it comes to Kubernetes and having multiple development teams, multiple users within your business units, unless they are within the core DevOps group actually sort of looking after the Kubernetes services and clusters, most commonly they're likely to know what relates to them. So possibly a namespace, maybe a service, maybe a deployment that they're using. And that's the language that they're going to use to talk to you about this thing. I've got a problem with my payment service. I've got a problem with my authentication service. What is relevant to them? Not I have a issue on node ABC, XYZ, that's unlikely to be what's going to come up for them. The deployment or the service much more likely to be how they wish to engage you on what the potential issues are. So that's a bit of sort of like troubleshooting type information. Now, one of the things which is really handy here is the fact that this view works across a number of various applications. So if you're using something like Twistlock, this ties directly in. So you can investigate your clusters and your vulnerability scans. Now, if you're using things like, if you do actually install our Falco events, this allows you to have a look at what's going on with your audit rules as well. So having a heads up view of what's going on from that security state as well. The rules which have been triggered, like anonymous requests, whether or not there's been service accounts created, attaching or execing to a particular pod, creating disallowed namespaces. These are all things which are really, really useful to see, and these are also events which can then be fed through to things like our CloudSeam Enterprise if you are using that as well. Now, what I really like about this is the fact that it provides a consistent view for multi-cloud. So if you're using AKS on Azure or EKS on Amazon or GKE on Google, everything looks the same. The collection methods might differ a little bit. Excuse me. The collection method might differ a little bit for some of the audit logs and things like that between the cloud providers, but basically it gives you a nice consistent view. But if you are using something like AKS and you want to know what's going on with the API server, we can show you that. If you're using EKS and you want to see what's going on with your API server audits, which URLs am I having problems with? Where am I getting my non-200 results? Who are my active users? These things are all exposed via the cloud providers. They all give a slightly different set, but we allow you to explore and visualize and alert on these things as well. Because even though it's a managed service, there are things which are of interest generally. And how we actually deal with that is within our app catalog. If you go to Kubernetes, you can see here that we have our Kubernetes app, but then we also have control plane apps for EKS, AKS, GKE, and a roll your own or standard. But a good example here too is some of the other Kubernetes ecosystem apps that we have. So things like Aqua Security, Twistlock, JFrog X-Ray, and then things for service mesh like Istio or Ingress. So these are all really useful things. And once again, the particularly useful thing is that they're all sort of available within this same environment. So if I'm using Aqua for container security, sorry, that's not showing up for me. Or StackRox. So if we're looking at StackRox image violations, okay, I can see which CVEs I've got by severity or cluster, bad image components, and so these provide just a really useful, easy way to explore through that data that you're getting from things like StackRox or JFrog X-Ray. Now, jump back to my slides for a moment, and we'll actually have a bit of a discussion about how we actually collect and get this data in. So basically, for Kubernetes, data collection is a little bit different than you may have seen with other Sumo Logic sort of traditional logging, excuse me, with our collector. So basically, this is a completely cloud-native computing foundation governed collection strategy. So we have our logs, which are collected by a fluent bit daemon set. Events are pulled from the Kubernetes API server using a plugin that we wrote for FluentD. Metrics are collected using a Prometheus operator, and the security events, as mentioned, come via Falco, which is a kernel level anomaly detection tool. It's an open source one. If you've heard of Sysdig, that's related to that project. It's a project, open source project that Sysdig have done, but that's optional. But if you have no other container security tooling that you're using, it's a really good idea because it's not an attack surface that you wish to leave completely open and unmonitored. Now, the secret sauce for us is this enrichment pipeline. So basically, every single log, event, metric, security event that you have coming through runs through this enrichment pipeline. And along with the sort of traditional tags of node, pod, and container, we're enriching this with service, deployment, and namespace. And that's what allows me to pivot through those various views that I have within the environment and tag that data and allow for that much easier sort of correlation and exploration of that data set. So it's a human-centered view. It works with how people understand their data to exist. That service-centric view versus an infrastructure view. And so this is what we talk about discoverability. So the important thing here is once you're installed that that collection with the Helm chart, so all of this can be deployed via a single line Helm chart command. Everything gets pulled down, and basically everything is auto-discovered. So when a new pod comes in, it's automatically known about. You don't need to manually do anything for that instrumentation to work. It's pulling those logs in, pulling those metrics in automatically as everything comes in. And importantly, because all of these pods are distributed across the various nodes, if you're looking at things and sorting things through an infrastructure-centric viewpoint, it's very difficult to find what you're looking for. It's complex, it's slow, it's hard to troubleshoot, and importantly, it's disconnected from the customer reality, be that your internal customers or your external customers. Now, the service-centric viewpoint, that gives a bit more order to things. It follows some logical processes of thought, and it fits the mental model that people have for Kubernetes. And more importantly, it's simple to understand. So it's quicker to find and troubleshoot issues, and it is tightly connected to that customer reality. People know that there is a user service or a mapping service or a authentication service, and that makes sense to how they're going to communicate those issues to someone who may be involved with that troubleshooting. And so a little bit more on the ecosystem side of things. So this isn't just stuff that Sumo has been developing. So we've also got a lot of partners in this environment, and that sort of works across both the security side of the coin, so things like Twixlock and StackRox, Aqua, JFrog X-Ray, and then over to sort of like more of the CI/CD tooling pipeline things. So we've got apps from people like CircleCI and CodeFresh and Harness. So everything that sort of works across DevOps and SecOps, and we're really seeing more of that sort of DevSecOps type model where security isn't something that sits off to the side. It's something which is integral to what people are trying to achieve within their organizations. And we think that we've built some tooling here which is particularly fit for purpose for that model, allowing people to explore, alert, monitor, and visualize what's going on in their environments. So what I would say is if this interests you, try it out. So you can sign up for a free trial of Sumo Logic. It takes minutes to get up and running. You can download the Helm chart from our GitHub and get it up and running on a test cluster in literal minutes. If you wish to have a chat to us, feel free to jump onto our public Slack channel. So you can go to slack.sumologic.com and join in there. And if you wish to ask some questions, there's plenty of our engineers, and I'm generally in there as well, and other customers also that you can have a chat to. Or feel free to reach out on the website, and we'd be more than happy to have a solution engineer have a chat to you if you wish to get some more information on that. So thank you very much. Once again, my name's Eddie Thompson, and really appreciate you taking the time to run through this with me. And I hope it's been informative, if not entertaining. Thanks very much. Cheers.